In this video, we're going to be talking about properties of exponents once again, but we're specifically going to be looking at the property of what happens when we raise a power to a power. Now, recall once again that an exponent, okay, is a little number that we put in the top right-hand corner on a base, which could be a variable or a number. The exponent tells us how many times we're multiplying that base together. So if I have x to the third, that would really be saying that I'm taking x times x times x, a total of 3 times. Okay, this idea is going to be important when we start raising a power to a power. Now, what raising a power to a power means is that we have some expression, some base. Okay, so this x is my base. And notice that is being raised to the second power, to an exponent of 2. But we also are taking x squared and we're raising that to a power of 3. So both the 3 and the 2 are both exponents. Okay, they are both exponents. So we're raising an exponent to an additional exponent. Okay, that's what this rule is looking at. That's what it means to raise a power to a power. We're taking an exponent and we're raising it to another exponent. Now, if we think about what exponents mean, we can think about what this 3 means. This 3 means that we're taking everything inside of the parentheses to the third power, meaning we're taking x squared times x squared times x squared, a total of 3 times. Okay, so I have x squared multiplied by itself, a total of 3 times. Then each of the x squareds individually tell me that I'm taking the base times itself 2 times. So for example, this would break apart into x times x, and this one as well would break into x times x, and then lastly this one would break into x times x. And if I take each of these pairs of x's being multiplied and I multiply those pairs together, in total I will have multiplied 1, 2, 3, 4, 5, 6. So in total, I would have x to the sixth. Okay. Now, it's likely in class you learned a shortcut for simplifying these so you didn't have to do all this work. Notice if I take the exponents 2 and 3 and I multiply them together, well, 2 times 3 is 6. So anytime I raise a power to a power, I just have to multiply the exponents. Okay? So anytime we raise a power to a power on an expression, you just take the two numbers, you multiply them together, and that will give you the simplified version. Now, let's see this again. So if I look at example 2, here I have x to the fourth, and I'm raising it to the second power. So raising something to the second power means that I'm taking everything in there, so the x to the fourth, and I'm multiplying it by itself twice. Okay, so I'm taking x to the fourth times x to the fourth. That's what it means to be taken to the second power. Then each of the x to the fourths means that I'm taking x times itself 4 times. So I have one group of 4, and I have an additional group of 4. Now, when I multiply those two groups of 4 together, I'm now multiplying a total of 8 of them. So I would get x to the 8th. Once again, if I don't want to do this work in the middle, I can skip it by knowing my rule that when I raise a power to a power, I multiply the exponents. Well, if I take 4 and I times by 2, I get x to the 8th. Okay, so this shortcut's going to save us this work. Now, once again, this is important because as numbers start getting bigger, we don't want to write out all this expansion form. We want to be able to use our rule to get the answer quicker. So if I look, I'm taking x to the 7th and I'm raising it to the third power. So I can simply just multiply the exponents together. So if I take x to the 7th times 3, I'm going to get x to the 21st power as my simplified version. Now, notice in all three of these examples so far, we've only had one base and one exponent inside the parentheses. If I look at number 4, here we have two bases. I have an x that's a base and I have a y that's a base. Every base will always come with its own exponent. Okay, so the x has an exponent of 2 on it, and the y has an exponent of 3 on it, and we're taking that whole expression to the fourth power. Now, what that means is when we do this rule of raising a power to a power, we have to multiply this outside exponent to each of the exponents inside the parentheses. Okay? It's important that we're multiplying exponents to the exponents. We never multiply an exponent to a base. We only multiply the exponent to the exponent. Okay? So if we do this, 2 times 4 is 8, so I get x to the 8th. And then if I take 4 times 3, well, that's 12, so I would get y to the 12th. Okay? Once again, I want to highlight that rule. We only multiply exponents to exponents, never exponents to bases. All right, let's look at a few more examples here. So, looking at number 5, here I have 3 variables. I know each of them should have their own exponent. You'll notice on the z, it looks like it doesn't have its own exponent. Anytime you have a variable by itself without an exponent, that's really a 1 on it. Okay, so you can go ahead and write the 1 in. Now, our rule, when we raise powers to a power, we can multiply the exponent. So I have to take this 2 and multiply it to each of the exponents on the inside of the parentheses. Okay, and it's important to remember exponents to exponents. Well, 4 times 2 is 8, so I get x to the 8th. 9 times 2 is 18, so I get y to the 18th power. And then if I take 2 times 1, well, that's just 2, so I get z to the 2nd power. Okay, so this would be my answer. Now, sometimes we can also have fractions inside of the parentheses. So if we look at number 6, you'll notice this is a fraction inside of the parentheses that's being squared or being taken to the 2nd power. Once again, though, we're still going to distribute this exponent to each of the exponents on all of our bases inside the parentheses. So notice we have 3 different bases. 3 is a base, x is a base, and y is a base. Okay, right now the x and y tell me what the exponents are. I need to know that the 3 is to the 1st power. It has an exponent of 1 on it. Okay, when we do this, we're multiplying the exponent to the exponents. Okay, never multiply the exponent to the base. What I mean by that is don't take 2 times 3. Okay, we're not multiplying 2 times 3. We're taking 3 to the 2nd power. Okay, so when we distribute, we're distributing to the 1. So we get 3 squared. Then when I take x to the 8th, and I'm taking that to the 2nd power, 8 times 2 is 16, so I get x to the 16th over y, and then when I take 5 times 2, that's 10, so I'm going to get y to the 10th. Now, I'm not quite done. 3 squared, I know, is really the same thing as 3 times 3, and 3 times 3 is 9, so the simplified version would be 9x to the 16th over y to the 10th. Okay, this should be my answer. Now, the number one mistake that we'll likely see from students are students who multiply the exponent to this number out front. What they'll do instead is they will keep the x to the 16th over y to the 10th. That part usually goes well. But the mistake that's common for people to make is they'll take this 2 on the outside and they'll multiply it by the 3 out front and they will get a 6 here. Okay, that is incorrect. We are not taking 2 times 3. We're taking the base of 3 to the 2nd power, and 3 squared is really a 9. Okay, so it's important that whenever you distribute this exponent, it's only 2 exponents. All right, let's try one last one real quick here. So if I take 2x divided by y to the 3rd, and everything's taken to the 3rd power, I want to distribute the 3 in. Now, when I distribute the 3, I have to distribute it to the exponent. So notice the 2 has an exponent of 1 on it, and the x has an exponent of 1 on it. So 1 times 3 is 3, so I get 2 to the 3rd. 1 times 3 is 3, so I get x to the 3rd. And then 3 times 3 is 9, so I get y to the 9th on the bottom. Now, once again, I'm not quite done. I need to simplify this 2 to the 3rd. Well, 2 to the 3rd is really 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So my final answer will be 8x to the 3rd, y to the 9th. All right, just a quick recap then here at the end. When we raise a power to a power, remember we're multiplying the exponents together. And I just want to emphasize that idea that we're multiplying exponents. You never multiply an exponent to a base. You only multiply exponents to exponents.